Imagine a planet so strange, so unlike anything else in our solar system, that it quite literally rolls around the sun on its side. Its poles point where other planets' equators do. Its rings orbit vertically. Its seasons last over 20 years. And if you stood near its equator, up and down would be directions that mean almost nothing. This is Uranus, the ice giant that defies every rule of planetary behavior. But beneath its calm turquoise glow lies one of the greatest mysteries in our cosmic neighborhood. Why did Uranus fall over? For centuries, Uranus was invisible to human eyes. It hid in plain sight, faintly glowing in the night sky, mistaken for a star by astronomers who lacked the tools to see its true nature. It wasn't until 1781 that a musician-turned-astronomer named William Herschel spotted it through a telescope and realized it was a planet, a discovery that expanded the known boundaries of our solar system for the first time in recorded history. At first, Herschel thought he had found a comet. The idea that there could be another planet beyond Saturn was almost too radical to consider. But as astronomers tracked its orbit, they realized this comet moved in a smooth, nearly circular path around the sun. It wasn't a comet. It was something far more monumental, a new world. And yet, even at its discovery, Uranus was an oddball. When scientists later studied its rotation, they were baffled. Uranus doesn't spin upright like Earth or even slightly tilted like Mars. Instead, it's tipped over nearly 98 degrees, essentially lying on its side. Its poles point almost directly toward the sun, meaning that for half of its 84-year orbit, one hemisphere basks in continuous daylight while the other is locked in total darkness. Imagine living on a planet where winter means decades without sunlight. The mystery of that tilt became one of planetary science's most perplexing riddles. How does a world end up like this? The most popular theory suggests a violent past. Billions of years ago, during the chaotic early days of the solar system, a massive object, perhaps the size of Earth, crashed into Uranus. The impact was catastrophic, knocking the planet onto its side and possibly even reshaping its internal structure. But there's a twist. Computer simulations suggest that a single collision might not fully explain Uranus's strange features. The planet's moon's orbit in near-perfect alignment with its tilted axis, implying that the entire system, planet, rings, and moons, was reoriented together. If a single giant impact had done that, the moons should have been scattered or destroyed. So some scientists propose not one impact but two, or perhaps a series of smaller collisions that slowly toppled Uranus over time. Others suggest something even more mysterious, that Uranus once had a massive ancient moon whose gravitational influence slowly tipped the planet before drifting away or being destroyed. It's a cosmic whodunit with multiple suspects and no clear culprit. Then there's the planet itself. At first glance, Uranus looks serene, a smooth, pale blue orb drifting in the dark. But don't be fooled. That tranquil facade hides an atmosphere filled with secrets. The blue color comes from methane gas, which absorbs red light and reflects blue. Yet beneath that icy hue lies a cocktail of hydrogen, helium, water, and exotic ices, ammonia, methane, and possibly even diamonds. Yes, diamonds. Deep within Uranus's mantle, the pressure is so intense that scientists believe carbon atoms could be crushed into crystalline diamond rain, falling for thousands of kilometers before settling into an ocean of molten slush. A literal storm of jewels, forever hidden beneath an atmosphere of frozen gas. But that's not the only mystery lurking in the planet's depths. Uranus's magnetic field is utterly bizarre. Most planets generate magnetic fields roughly aligned with their rotation, like Earth's. Uranus? Its magnetic field is tilted 60 degrees away from its axis and doesn't even pass through the planet's center. Instead, it's lopsided, like a magnet carelessly glued to one side of a spinning ball. This means its magnetic field fluctuates wildly as Uranus rotates, creating strange and unpredictable auroras. Unlike the symmetrical ethereal lights dancing over Earth's poles, Uranus's auroras appear in odd places, sometimes far from either pole, flashing briefly before disappearing again. They're a cosmic reminder that on Uranus, nothing behaves as expected. And yet, for all we know, we've barely scratched the surface. To date, only one spacecraft has ever visited Uranus, Voyager 2 in 1986. It raced past at 80,000 kilometers per hour, snapping a few photographs and collecting data during a fleeting encounter that lasted mere hours. What it saw astonished scientists, a pale blue sphere, featureless at first glance, but surrounded by faint rings and accompanied by a retinue of curious moons. Voyager 2 revealed that Uranus has at least 27 known moons, each named after characters from the works of Shakespeare and Alexander Pope. Titania, Oberon, Miranda, Ariel, Umbriel, all unique worlds orbiting a tilted king. And Miranda, in particular, stands out. Its surface is scarred by cliffs 20 kilometers high and canyons deep enough to swallow Mount Everest twice over. It looks like a moon torn apart and stitched back together, a Frankenstein of rock and ice, possibly reshaped by gravitational forces during Uranus's violent past. Despite that glimpse, the planet remains shrouded in mystery. Voyager 2's instruments were primitive by today's standards. We don't know what drives Uranus's internal heat, or rather its lack of it. Unlike its sibling Neptune, which radiates far more heat than it receives from the Sun, Uranus seems almost cold. It emits very little internal energy, as though something long ago extinguished its internal furnace. Some scientists think the catastrophic event that tilted the planet might have also vented its heat into space. Others wonder if Uranus was simply born differently, its interior layers mixed in ways that trap warmth deep below. It's a planet that refuses to play by the rules, from its spin to its heat to its magnetic field. And as strange as it is, Uranus might be more important than we realize. Astronomers now believe that ice giants like Uranus and Neptune could be the most common type of planet in the universe. While we once thought gas giants like Jupiter were typical, exoplanet discoveries suggest that Neptune-sized worlds dominate the galaxy. Studying Uranus could reveal the blueprint for countless other planets orbiting distant stars. Yet, incredibly, we've left it mostly unexplored. For nearly 40 years, Uranus has been waiting in the cold, unvisited and silent, its secrets frozen in time. But that might soon change. NASA and other space agencies are planning new missions to the ice giants, possibly within the next 2 decades. The Uranus orbiter and probe, currently under study, could finally reveal what lies beneath those icy clouds, how its moons formed, and what cosmic event tilted it sideways in the first place. Imagine the moment when a new spacecraft arrives, orbiting that tilted world, diving through its rings, mapping its magnetic chaos, and peering into its diamond-filled depths. It would be our first true exploration of a planet unlike any other, a world that challenges everything we know about how solar systems form. So the next time you look at a diagram of the solar system, those neat little circles, all perfectly aligned, remember Uranus, the quiet rebel, the sideways wanderer, the ice giant that turned its back on the sun and rolled into eternity. It reminds us that even in the clockwork precision of the cosmos, there is room for the extraordinary. That sometimes, to understand the universe, we must look to the worlds that refuse to fit the mold. Because in the tilted orbit of Uranus lies a truth about the cosmos itself. Perfection is rare, but strangeness is everywhere.